For decades, the map of our solar system was considered charted territory. And within it, some 1.4 billion kilometers away, orbited a doomed moon, Enceladus. Scientists had cataloged it as a mere block of ice, an inert object devoid of internal energy. Cold, dark, and geologically dead. A place that could hold no secrets. But the Cassini spacecraft, on its final and fateful journeys, captured an image that defied all established science. In just 24 hours, that pale ball of ice didn't just keep a secret. It rewrote the entire rulebook on where to look for life. What definitive discovery, in the most unlikely of places, convinced the scientific community that an ocean lies hidden beneath that ice? To understand the impact, we must go back to 1997. The Cassini-Huygens mission was launched with a monumental objective: to spend more than a decade exploring the giant Saturn, its rings, and its largest moon, Titan. Enceladus was just a footnote, a low-priority target. Cassini's design was a feat of engineering. For 13 years, it operated in the frozen darkness of space, revealing unprecedented cosmic beauty. But it was in 2005, barely a year after inserting itself into Saturn's orbit, during one of its initial flybys, that something baffling appeared at Enceladus's south pole. It shouldn't have been possible. NASA's thermal models indicated this moon should be a uniform, frozen rock. But from the tiger stripes, those mysterious fractures near the pole, sprays of ice particles were observed. Something that simply shouldn't be there. This phenomenon forced NASA to make a radical decision. Enceladus stopped being a footnote and became the primary mission. Titan was originally the star of the show. It is larger than the planet Mercury. It is blanketed by a nitrogen atmosphere and holds lakes of liquid methane on its surface. But the discovery of those icy plumes on Enceladus was just the beginning. Mission scientists realized the plumes acted as windows. If they could fly through them, they could effectively sample the interior of Enceladus. So, they designed a series of extremely risky flybys directly through that frozen vapor. Cassini carried something far more valuable than just a camera, a sophisticated spectrometer and a dust and particle analyzer. When the spacecraft pierced the plume, its instruments revealed that what was spewing from Enceladus wasn't simple water vapor. It was salt water. The presence of salt proved the existence of an ocean, but the definitive proof came with the detection of silica and organic molecules. For silica particles to exist, the water must be boiling at over 90 degrees Celsius at the bottom of the ocean, interacting with the rocky core. This is the crucial point that rewrote history. It is not just an ocean, it is a warm, active one, containing all the basic ingredients that made life possible on Earth. The finding at Enceladus was not the discovery of life itself, but the discovery of the factory where life could be assembled, right beneath the surface. What began as a footnote had become the best candidate for extraterrestrial life in our own cosmic backyard. The discovery of a warm, salty, active ocean beyond the orbit of Jupiter was an intellectual shockwave. For decades, astrobiology had focused almost all its resources on the band around the Sun, where liquid water can exist on the surface. Enceladus proved that premise incomplete. For life, what matters is not proximity to the Sun, but an internal heat source that keeps water liquid. The so-called ocean worlds became overnight the top candidates for life. This shift has rewritten future exploration plans. Missions no longer seek just planets. They seek active chemistry. That is why today, NASA has dedicated massive resources to missions like Europa Clipper to study the subsurface of Jupiter's system. The legacy of Enceladus is not just what we found, but where it forced us to look. The discovery of Enceladus posed an ethical dilemma. After 13 years of service, Cassini was running out of fuel. If left to orbit uncontrollably, there was a small but real chance it could crash into Enceladus, contaminating its precious ocean with Earth bacteria. In 2017, NASA made a heroic decision. Cassini was to be sent into a grand finale in Saturn's atmosphere, a final act of sacrifice to protect the life it had just discovered. The spacecraft that proved the existence of an ocean could not be the one to destroy it. Enceladus reminded us that life is not an exclusive miracle. It showed us that the factories of life can operate in the icy darkness, far from the warmth of our sun. If this tiny moon, billions of kilometers away, holds the conditions, what else have we overlooked? The next time we look at Saturn, we will no longer see a boring speck of ice. We will see an ocean of possibilities